This call is
In continuation of the geometry of molecule, we will learn this time deeply on what is really a covalent bond. So for this lesson, we will be defining covalent bond on a molecular level, how it is formed, what are the characteristics that gives it strength, and also we will be able to understand in this topic the concepts that will help us explain molecular shapes based on the interactions of atomic orbitals in relation to covalent bond formation. Now, the most useful approach in answering these questions is the theory of valence bond. Now, this theory particularly states that a covalent bond forms when orbitals of two atoms overlap. And on that overlapping region, a pair of electrons occupy. Now, since on the preceding slides, there are atomic orbitals that will be presented, it would be a good idea to recall first some of the important concepts on atomic orbital. So recall natin, when we say atomic orbital, this can be thought of as a subshell that surrounds an atom. Okay, and also this is where electrons can be found. It is a region that surrounds an atom where there is a highest probability of finding an electron. That is atomic orbital. Alright, and we have a set of quantum numbers that describes an atomic orbital. We have the principal quantum number that indicates the size of the atom, or it also describes the or relates to the highest energy level of an atom. Okay, Azimuthal quantum number, this is the quantum number that relates to the shape of the atomic orbital, and we have magnetic quantum number that describes the orientation naman of the atomic orbital. Now, for this lesson, at least man lang you recall the importance of azimuthal quantum number. So, recall natin yung azimuthal quantum number, diba? Or this is designated also with the symbol small letter L, okay, or an italic L. When I say azimuthal quantum number, this could be any number, okay, any integer from 0 to n minus 1. And take note, whatever value that you get for L or azimuthal quantum number, whatever azimuthal quantum number that you get, or resulted based on the n value that is given, that value designates a particular shape. Okay, let's say for example, if the L value is 0, that is an S sublevel and the shape of the orbital is spherical. If L is 1, that is a P sublevel and the shape of that orbital for P is somehow a pair of lobes that extends on its axis, and there are about three orbitals for P sublevel, and if L is 2, that is D sublevel. It looks like a clover shape, and if L is 3, we have the 7 orientations for F. This would be F sublevel. Okay, we have 7 orientations, and it looks like yung shape niya perpendicular to each other. Alright, now for this lesson, at least you familiarize the shape of the S and P. Alright, the S orbital spherical, the P orbitals, right? The P orbitals, it looks like a pair of lobes. It looks like a dumbbell shaped. Okay, so that is for the shape of the orbitals. And another thing that that also gives importance to atomic orbital, no, is that they can be used to describe distribution of electrons of an atom. Diba? Kaya nating ma-determine yung electronic configuration of an atom, okay, based on the atomic orbitals. Alright, so say for example, recall that yung carbon, it has the atomic number of 6. Therefore, for a neutral atom of carbon with 6 atomic number, it will also have 6 number of electrons. Alright, and that 6 number of electrons resides on first 2 in 1s orbital. Another 2 electrons resides on the 2s orbital, and under 2p orbital we have 2 unpaired, okay, electrons. All right, so that is also the importance of these orbitals, SVDF. Okay, so as mentioned earlier, diba, this is very important because it is where electrons resides, it is where electrons occupied. Alright, and recall that on the highest level, energy level, highest subshell, we can find there the valence electrons. Okay, so we have here the valence electrons, or the electrons that are found on the outermost shell. Alright, so we have 4 valence electron for the atom carbon. Okay, and take note, when we say valence electrons, those are the electrons that are involved in bonding, that are involved in chemical reactions. Alright, so for carbon, always, carbon will share its 4 valence electron, forming 4 covalent bonds. Now, in forming a bond, specifically a covalent bond, we have this theory, the valence bond theory, that explains a lot on how a covalent bond is formed. Alright, so this slide was presented already earlier. So recall lang natin yung principle, basic principle of this theory. It states that a covalent bond, okay, is being formed when orbitals of 2 atoms overlap. Okay, and on that overlapping region, we have a pair of electrons that occupy. Alright, so say for example, you have this orbital, a spherical, an s orbital of a particular atom, and another orbital, okay, of an atom. Okay, so that is already orbitals of 2 atom. Let's say that 2 atom is hydrogen. Okay, for example, the simplest molecule that would help us explain this concept is through the molecule of hydrogen gas. Diba? Yung hydrogen gas, it is a diatomic molecule. You have atoms of hydrogen bonded together. Okay, so this is an example of a covalent bond. Now, according to valence bond theory, a covalent bond, it is being formed when orbitals of 2 atoms overlap. Now, hydrogen, okay, on the left side, recall that it has 1 valence electron that resides on its 1s orbital, an s orbital. An s orbital has a spherical shape. Okay, so let's say this 1s orbital of hydrogen on the left side has 1 electron, 1 valence electron on its 1s. Of course, the other hydrogen also has the same number of valence electron, which also resides on 1s orbital. So another spherical orbital, kasi an s orbital has spherical shape. So, overlap yan. Okay? On this overlapping region, ayan, this is the overlapping region. Okay? On that overlapping region, a pair of electrons occupy. That is how a covalent bond is formed based on the valence bond theory. All right? You have orbitals of two atoms overlap. Okay? On that region where the orbitals overlap, okay, that is where a pair of electrons will occupy. And as a requirement, based on the Pauli's exclusion principle, di ba? Recall, ano yung sabi sa Pauli's exclusion principle? Pauli's exclusion principle, ano sabi dito? Di ba? Sabi dito, any atom can have the same set of quantum numbers. At least, they must differ lang sa spin of electrons. That is why the moment that electrons occupy the orbital, they must at least have opposite spin. Okay? And of course, an orbital, a single orbital, okay, can only hold up to 2 electrons, and that 2 electrons must have again opposite spins as a requirement by Pauli's exclusion principle. So this would be the simplest case for valence bond theory. How covalent bond is formed in a hydrogen gas molecule. You have 1s orbitals of 2 hydrogens. They overlap and electrons are being paired. Another simple example would be in the formation of covalent bond in the molecule of hydrofluoric acid. Okay, so how this covalent bond is formed. All right, so no problem with hydrogen. We all know already that a hydrogen has one valence electron that resides on its 1s orbital. So let's say, for example, this is 1s orbital. A 1s orbital with one unpaired electron. Now, what about fluorine? Okay, sige, recall natin, when you distribute the electrons of chlorine in its orbital, diba, it has how many number of electrons? Diba? It has 9. Tama ba? 9. Fluorine has a neutral fluorine. It has 9 electrons. Okay. Of course, it will reside first on yung first 2. It will reside on the lowest energy level, 1s2, followed by 2s. So we already have 4. Then after 2s, we have 2p. Ayan. So total of 9. Tama? 2, 4, 6, 8, 9. Alright, so this is how the electrons of fluorine being distributed on its orbital. Now, as you observed, on its 2p, one of the 2p orbital of fluorine, it is half filled. Okay, one of the 2p orbital of fluorine is half filled, meaning meron siyang isang unpaired electron. Okay, and nagkataon si hydrogen meron din siyang isang unpaired electron. Therefore, most probably, pwede silang mag-share ng electrons para ma-attain nila yung stability. But this time, yung overlapping, yung shape ng orbitals that overlaps, different na yung shape kasi this is already a p orbital. Okay? And ano nga ulit yung itsura ng p orbital? Diba? It looks like a pair of lobes that extends along its axis. Say for example, you have a fluorine. So, hypothetical lang, it looks like this. No? So, parang ganito. So you have a 1,2p orbital of fluorine. And say, for example, this is fluorine. Okay. This is one of its 2p orbital, which is half filled. Okay. Ayan. Okay. So this is how this covalent bond between hydrofluoric, no? Between hydrofluoric acid is being formed. You have a 1s half-filled, 1s orbital of hydrogen overlaps to the half-filled orbital of 2p of fluorine. Okay, 1s orbital of hydrogen overlaps a half-filled 2p orbital of fluorine. Okay, that is how covalent bond is formed in the molecule of hydrofluoric acid. Okay, so I hope nakuha na yung concept no, ng valence bond theory. You have orbitals of two atoms. Orbitals of two atoms overlap. On that overlapping region, on this overlapping region, that is where a pair of electrons will occupy. And with opposite spins. Sige, another example. Let's have another diatomic molecule, yung fluorine gas. Okay? Fluorine gas, another diatomic molecule. So you have two atoms ng fluorine being bonded. So this is another covalent bond. So, na-present na kanina ano yung half-filled orbital ng fluorine. And that is, meron silang 2p, isang 2p orbital nga half-filled. Ganun din, yung isang fluorine, meron siyang half-filled na 2p orbital. Therefore, hypothetically, we can imagine nga yung overlapping will look like this. Okay. Ayan. Okay, so let's imagine, for instance, this is the first fluorine on the left side. Ito yung half-filled 2p niya. So, meron siyang half-filled na 2p. Then, ito yung isang fluorine on the right side. Ito yung half-filled naman niya na 2p orbital. Alright? So, merong half-filled 2p orbitals that interacts end-to-end. Okay, so ito yung overlapping region. That is how this covalent bond is being formed. Okay, so that is the concept, the basic principle of valence bond theory. You have orbitals of two atoms overlap. Okay, and on that overlapping region, doon nagpe-pair up yung electrons. Alright, so this is the importance of valence bond theory in understanding how covalent bond is formed. However, this is only the case for the bonding in diatomic molecules. Okay? Madali lang nating maintindihan yung valence bond theory kung diatomic lang yung given na molecules. When you say diatomic, dalawa lang yung atoms in that molecule. Okay? Walang central atom, kumbaga. Okay? So this is the only case for bonding in diatomic molecules. Kasi madali lang nating ma-picture out, di ba? Yung direct overlapping ng S tsaka P orbital or S to S or P to P orbitals of an isolated atom. But how do we account ba? How do we account for the formation of covalent bonds kapag yung molecule meron ng central atom? Okay? And how do we account for the shape of the molecule from the orientation of the atomic orbitals? Okay? So let's try to answer that based on the molecule of methane. Okay? So, for example, in the case of methane, Okay? As you'll observe, yung methane, the simplest organic compound, CH4, it has this structural formula. Okay? So, yan yung formula niya. You have a carbon as the central atom. Carbon as the central atom. It forms 4 single bonds. Alright? Or it forms 4 covalent bonds towards hydrogen. However, if we try to check, okay, the distribution of electrons in carbon and then relate it to the theory of valence bond, how covalent bond is being formed, the theory itself cannot explain correctly the existence of this molecule. Let's try to find out. Okay, let's start with the electronic configuration of carbon as the central atom. Diba, recall, kanina pinakita ko naman the distribution of electrons for the atom of carbon. Again, it has 6. No? It has 6 electrons that surrounds the atom of carbon. Okay? From that 6, dalawa doon resides on the lowest energy level, 1s, and on its highest energy level, which is the second level, doon natin makikita yung 4 na valence electron ng carbon. Nasa 2s yung dalawa singly distributed to orbitals of 2p. Okay? Based on the distribution of electrons in the atom of carbon, it only resulted two half-filled 2p orbitals. Okay, 2 half-filled 2p orbitals. We could realize then that if dalawa lang yung half-filled 2p orbitals, that could only overlap as well 2 equivalent 1s orbital of hydrogen. Thus, obviously, it will just form 2 carbon to hydrogen bonds. Alright? Dalawa lang yung possible carbon to hydrogen bonds na mabubuo, forming CH2. And CH2 is an unstable molecule. Okay, wala namang CH2 na molecule, knowing that carbon having 4 valence electron, it will always share its 4 valence electrons, forming 4 covalent bonds. So, yung nangyari dito, yung valence bond theory alone, it failed to explain how the molecule of methane exists. Alright? That is based on the distribution of electrons in the atom of carbon. Yung nag-result lang kasi, dalawa lang yung half-filled orbital ng 2p. Dalawa lang yung unpaired. Therefore, dalawa lang din yung posibleng p orbitals that could overlap to the 1s orbital ng dalawang hydrogen, forming CH2. So, yan yung, kumbaga, realization kung magbe-base tayo sa original na electronic configuration ng isolated carbon atom. Okay? So, in this case, paano natin ngayon ma-explain yung existence ng mga molecules forming covalent bonds with a central atom? Alright? Paano sila nagfo-form ng covalent bonds, yung mga molecules na may central atom? Okay, which is also, that will be supported then secondarily by valence bond theory. So, in order to form 4 bonds in the case of carbon in the molecule of methane, the configuration of carbon dapat it must have 4 unpaired electrons. Alright? So, dapat natay 4 na unpaired electrons or 4 na half-filled orbitals. Okay? Para makabuo tayo ng 4 na covalent bonds. Alright? So, good thing we have Linus Pauling, who proposed the hybridization theory. Okay, so this theory helps explain molecular structure when valence bond theory failed to correctly predict their existence. So, when we say hybridization, hybrid, diba? Pag sinabing hybrid, it is synonymous to the term combination. No? Hybrid, this is combining or mixing 2 or more than 2 orbitals, atomic orbitals, to form a new set of equivalent atomic orbitals. Yung tawag doon sa new set, panibagong set ng equivalent atomic orbitals, they are known as hybrid orbital. So, say for example, di ba kanina, ito yung electronic configuration for the atom carbon. Tama? We have 1s2, 2s2, 2p, 2. Alright? So, kumbaga, yung sa tatlong orbital under 2p, okay, sa tatlong orbital under 2p sublevel, 2 lang yung half-filled. So, yung gusto nating mangyari is dapat makabuo ng 4 na bonds yung central carbon ng molecule ng methane, okay, para mabuo yung stable molecule. Alright? So, yung gagawin natin is hybridization. Magmimix tayo ng 2 or more atomic orbitals, depende sa kailangan natin, para makabuo ngayon ng new set of atomic orbitals. Okay? So, for the case of methane, ilan ba yung kailangan na group of electrons, okay, to form a stable number of bonds for methane? Diba? Kailangan natin ng 4, okay, na bonds. Para mabuo yung 4 na bonds, kailangan natin ng 4 na unpaired electron. So, magsisimula yung hybridization, yung combination mixing, of course, sa highest energy level. Okay, so dun lang magsisimula sa highest energy level. So, simula tayo sa S. Okay, sa 2S. So, magmimix tayo, isang S. Okay. Then, so isang orbital na yan. Okay. Then, mix natin isang P. Okay, so another orbital yan. Another, kulang pa, kailangan natin ng 4. Okay, so isa pang P. Okay, ayan, isa pang P. Then, yung last na P. Kung simplify natin yung orbital na to, this is already sp3. Okay, kung i-simplify natin, isang S, 3 yung P, so sp3. Kung ilan yung na-mix mo, na orbitals, yan dun yung equivalent number of hybrid atomic orbitals. Alright, so pag sinabing sp3, 4 yung available orbital dyan. Okay, so yung mangyayari, mix mo yan, yung 4 na orbital na to from the original. But this time, hindi na yan 2s, 2p, 2p, 2p. Yung mangyayari, the hybrid orbital is already sp3. Which is, ilan ulit yung orbital kapag sp3 hybrid orbitals? 4. Alright? So, kung may 4 ka na, sabi natin yung carbon has 4 valence electron. So, yung 4 na valence electron na yun, di ba? When we occupy electrons on sublevels with more than one orbital, they has to be distributed singly. Alright? That is based on the Hund's rule. Okay? So after 1s, meron kang sp3, apat na orbitals. Hybrid orbitals na sp3, which is apat. Okay? So 1s2, then distribute mo yung remaining apat singly bago yung pair up. But nagkataon na apat lang naman yung valence electron ng carbon. Alright? So wala ka na mapipair up dyan. Alright? So that is how hybridization happens. Okay? Which is a very important concept, especially in the formation of covalent bonds. Alright? So in general, there are actually five types of hybrid orbitals. Alright? 5 types of hybrid orbitals. Kasi naalala, meron tayong 5 geometric orientation. Related lang kasi sila. Okay? Yung 5 geometric orientation na yun, which is linear, trigonal planar, tetrahedral, trigonal bipyramidal, octahedral, na-form yung shape na yan also because of the way how the overlapping of orbitals or hybrid orbitals occur in a certain molecule. Alright? So, yung 5 hybrid orbitals na yon, una, we have sp. Ibig sabihin, we mixed isang s and isang p na pure atomic orbital ng central atom. So, nagmix ka ng isang s, then isang orbital ng p, so sp yan. Since dalawa yung na-mix mo from the pure atomic orbitals, that is equivalent to 2 hybrid orbitals. Ibig sabihin, pag sinabing sp, hybridization, dalawa yung orbitals available. We also have sp2. So this time, meron kang 3 available orbitals under sp2. These are hybrid, These are hybrid orbitals. New set of equivalent atomic orbitals. Okay? So when we say sp3, nagmix ka ng isang s, 3 p, so sp3, equivalent to 4 na hybrid orbitals. Okay? sp3d, so you have S, then 3 P, isang D. So that's a total of 5 orbitals. Then lastly, we have sp3d, 2. So obviously that is equivalent to 6 number of orbitals. And related lang yung molecular shape sa hybridization of central atom. Kapag yung molecule na yan forms a linear shape, ibig sabihin, yung hybridization ng central atom na yan is sp, hybridized. Kapag trigonal planar, yung shape, okay, ibig sabihin, yung central atom na yan, sp2, hybridized. Tetrahedral arrangement, as long as 4 yung surrounding na electron groups for that central atom, naka-sp3, hybridized yan. Trigonal bipyramidal, kapag 5 yung electron groups surrounding that central atom, naka-sp3d, hybridized yung central atom. Octahedral shape or arrangement, or 6 electron group arrangement for that central atom, naka-sp3d2, yung hybridization ng central atom. So, related lang yung hybridization of the central atom to its shape of hybrid orbitals. Alright? So, let's try to find out the rationale. Okay. Say, for example, for the molecule of beryllium chloride. So, this would be the Lewis structure for the molecule of beryllium chloride. And we all know that beryllium chloride will form a linear shape. Tama? Kasi yung central atom, it has two bonding groups, two electron groups surrounding the central atom beryllium. Therefore, it will form a linear shape. And hybridization of beryllium here is in sp, hybridized. Why? Okay. So, check natin yung, first, i-check natin yung electron distribution ng atom beryllium. Recall that beryllium has 4 atomic number. Right? Ibig sabihin, 4 yung number of electrons niya. Excuse me. So, yung 4 na yan resides on first 1s, and yung dalawa 2s, and empty yung 2p ng beryllium. Okay, so na-occupy na natin na distribute na natin yung 4 na electrons for the atom beryllium. But if we apply valence bond theory, wala siyang half-filled, wala siyang unpaired electron. So, paano niya nabuo itong dalawang covalent bond? Paano siya nagkaroon ng half-filled orbital? So, hybridization tayo. Okay? So, beryllium, yung gagawin natin dito, since in this molecule, dalawa yung nabuo niyang covalent bond, kailangan natin ng dalawang half-filled orbital. Okay? So, magsisimula yung hybridization ulit sa highest energy level. Okay? Or the outermost shell. Ilan ulit yung kailangan natin? Dalawa. So, isang S, isang 2p. Okay? Forming an sp hybrid orbital. Ilan yung orbital under sp hybrid orbital? Dalawa. Ilan yung valence electron ng beryllium? Dalawa. Okay? Wag kayong ma-confuse sa number of electrons versus valence electron. When say number of electrons, that is the total electrons in the atom of beryllium. But when we say valence electron, that is the number of electrons that is only found on the outermost shell. So we only have 2, knowing that beryllium is under group 2. Group 2 elements. Alright? So meron siyang dalawang valence electrons. So after 1s, you have sp. Distribute natin singly yung valence electron niya to the hybrid orbital sp. Okay, so this time, if you'll observed, upon mixing, okay, upon hybridization, we already produced 2 hybrid, half-filled hybrid orbitals of sp. And this can now overlap to the half-filled 3p orbital in each chlorine atoms. Alright? So, yung isang sp na half-filled, it will form an overlap with this carbon. The other sp hybrid orbital ng beryllium will form an overlapping mechanism with that of the orbital, half-filled orbital ng other chlorine atom, forming the covalent bond. So, sp hybridized yung beryllium dito. Alright? Okay, the same happens with the molecule of boron trifluoride. So, ganun lang din. If you recall the distribution of electrons for the isolated atom of boron, di ba? Meron siyang 5 total electrons yung boron. Okay, so kung isusulat natin yung distribution of electrons niya, it will result to 1s2, 2s2, and 2p1. So total of 5 electrons. And beryllium has 3, no? 3 valence electron. Tama? Kaya, under siya kasi under siya, diba, sa group 3 elements. Okay, group 3 elements. So, meaning meron siyang 3 valence electrons. So, capable siya mag-form ng 3 covalent bonds. But, as you'll observe, sa distribution ng electrons, isa lang yung half-filled 2p orbital. Okay, isa lang yung half-filled 2p orbital. So, yung gagawin ulit, mixing. Magme-mix tayo ng orbitals, atomic orbitals, para makabuo tayo ng bagong set of atomic orbitals para capable na yung central atom na boron to form 3 covalent bonds. Alright? So, yung mangyayari, mix tayo ng isang S, okay, and 2 p orbital. And that will form sp2. So we have 1, 2, 3. Okay. So from 1s2, okay, yung remaining 3 valence electron will be singly distributed to sp2. Alright. So this time, after mixing atomic orbitals, sa new hybrid orbitals, meron na tayong 3 half-filled na sp2 orbitals. And these 3 half-filled sp2 orbitals can now overlap to the 2p orbital of each fluorine. Alright? So, that is the rationale how covalent bond is being formed in the molecule of boron trifluoride. Naka-sp2 hybridized kasi yung central atom na boron. Okay, the same happens to the molecule of stannous chloride. Okay, kahit lone pair pa yan, as long as 3 yung electron groups, okay, that surrounds the central atom, sp2, hybridized pa rin yung central atom. So let's try to find out. Si tin, kung titingnan niyo yung periodic table, it has 50 total number of electrons. So, I will not show to you the distribution of electrons ng 50 na distribution of electrons ng tin kasi 50 yan. Sobrang dami. Maliit lang kasi yung board natin. So, yung gagawin ko lang is I will just present how the valence electrons of tin are being distributed. Pagdating sa 5th level, okay, which is 5, may D, may F orbital na, si tin, yung tin, meron siyang 4 na valence electron. Okay, kung isusulat niyo talaga manually, okay, yung distribution ng electrons for tin, ang pinaka highest energy level or highest outermost shell is 5th level. Okay, so dito natin makikita yung valence electron niya, which is total of 4. So, ganito yung pagkakadistribute sa 4 na yon na valence electron ng tin. Nasa 5s yung dalawa, then singly distributed yung another 2 sa 5p orbital. So, kung titingnan natin, dalawa lang yung half-filled. Diba? Dalawa lang yung half-filled orbital. So, ganun pa rin yung gagawin. Kailangan natin ng hybridization. Okay? Kailangan natin mag-mix ng pure atomic orbitals to form a new set of hybrid orbitals. Alright? So, ang mangyayari dito, mix tayo ng 3 ulit. Okay? Kasi, itong lone pair, kahit hindi yan nakabuo ng bond, syempre, any electrons will occupy in a certain orbital. Diba? Nasa orbital palagi yung electrons naka-reside. Okay? So, kailangan natin ng tatlong set ng orbital. Okay? So, mix ka ng 3, isang S, dalawang P. Kasi 3 lang yung need natin. And that will form sp2 pa rin. Okay? Isang S, then dalawang P. Dalawang P, so P2. Okay? Now, ngayon, when we distribute now the total valence electron ng tin, ang magiging resulta is upon distribution, ayan, magkakaroon na ng paired magkakaroon na ng paired electron yung isang hybrid orbital. Diba? Kasi 3 pa to. Okay, distribute singly. Kulang pa yan kasi 4 lahat yung valence electron ng tin. Okay? So, magkaka-pair up yung isang electron. Ibig sabihin, itong merong pair, okay, or itong paired electron na to sa sp2 orbital, this will be shown in a lone pair. Okay, ito yung lone pair na makikita natin dito. Okay? Ibig sabihin, itong partner na to na electron resides in one of the sp2 orbital of tin. The other half-filled sp2 nag-overlap each to the 3p orbital of each chlorine atoms. Okay? Itong isang half-filled na to overlaps to the orbital of one chlorine. Itong isang orbital na to overlaps to the other orbital ng isa pang chlorine, forming this 2 covalent bonds. Alright? So that is the rationale how the covalent bonds in stannous chloride is being formed. Now for the molecule of methane, na-explain naman siya kanina. So the same lang gihapon what happens to phosphonyl chloride, ammonia, sp3. Okay? So yung pinaka-clue nyo lang in order to determine the hybridization of the central atom of that molecule is simply count, no? Simply count the number of electron groups also that surrounds the central atom. Kung ilan yung electron groups that surrounds the central atom, yun yung total number of orbitals na kailangan mong i-mix. Okay? Okay, another example. For the molecule Ayan, of phosphorus pentachloride. So this time, yung central atom, sp3d. Okay, hybridized. Okay, sige, let's try to find out. Phosphorus, yung total number of electrons niya is 15. Sige, let's try to check the distribution of electrons. Ayan. So we have 2s, 2p, 3s. Okay. So, ayan. 2, 4, 6, 10, 12, and ayan. Alright. Now, as you can see, phosphorus, yung highest energy level niya is the third level. Alright? So, meron siyang ilang valence electron? 5. 5 valence electron for the atom phosphorus. But, as you can see, tatlo lang yung half-filled 3p orbital niya. Therefore, hindi yan kaya para makabuo ng 5 covalent bonds in the molecule of phosphorus pentachloride. So, mixing ulit yung mangyayari. Okay? Mixing ulit yung mangyayari. So, what will happen is from this highest energy level, mix ka ng 5 pure atomic orbital. So, isang S, syempre, 3 P, and isa pang, ayan, di ba, this is 3D. May D orbital na sa third level. So, para makabuo ka ng 5 half-filled orbital, mix ka ng 5 pure atomic orbitals. Okay? Isang S, 3 P, isang D. So, sp3d will have 5 orbitals. Okay? So, upon distribution of this valence electron for phosphorus singly. Ayan. So, meron ka ng 5 half-filled sp3d that will, sp3d orbitals that will overlap to each of the orbitals ng chlorine. Alright? And lastly, and we have the molecule of sulfur, hexafluoride. Okay? Sige, let's try to find out. Sulfur as the central atom. Paano siya makakabuo ng 6 na covalent bonds? Sige, let's find out first the distribution of electrons ng sulfur. So, siya yung may total 16 number of electrons. Okay? So, we have 2s, 2p, 3s, then 3p, 3d. Okay? Distribute 16 electrons. Okay? 12, 13, 14, 15, 16. Alright? So, ito yung magiging result ng distribution of electrons for the isolated atom of sulfur. Na kung titingnan nyo, 2 lang yung half-filled 3p orbital. So, ulit, hybridization. Magmimix tayo ng atomic orbitals to form 6 half-filled orbitals. So, isang S, 3 P, 3 D. So, 6 yan lahat. 1, 2, 3, 4, 5, 6. And that will form sp3, then 2 D, D2, which is equivalent to 6 orbitals. Ilan yung valence electron ng sulfur? 6. So, after 2p6, yung 6 na to will be distributed singly okay, to the hybrid orbital sp3d 2. Alright? So that is the explanation of the formation of covalent bonds in the molecule of sulfur hexachloride. This time we will learn the different using the following molecules: ethane, ethylene, acetylene, or ethane. We will be discussing two modes or ways of orbital overlapping. And since there are two modes, that will also result to two types of covalent bonds. So let's start first with the molecule of ethane. Now observe that in this molecule, each of the carbon is in tetrahedral shape. Tama? For this carbon, itong carbon na to, meron siyang apat na electron groups. Alright? So, 1, 2, 3, and 4. So, ibig sabihin, itong carbon na to, naka-tetrahedral yung shape niya. The same with the other carbon, the other central carbon on the right side. Meron din siyang apat na electron groups surrounding its atom. Naka-tetrahedral din yung shape niya. So, for this molecule, observed nga yung molecule ng ethane is tetrahedral at both carbons. Ibig sabihin, yung bond angles is near the ideal 109.5 degrees. And since tetrahedral in shape, we can conclude then that the hybridization of both central carbons are sp3 hybridized. Alright? So, naka-sp3 hybridized, ibig sabihin itong carbon na to, meron siyang apat na orbital nga sp3 hybrid orbitals, the other one as well. Okay? Particularly, both of the the carbon to carbon, itong carbon to carbon bond, ayan, they are it has sp3 orbital that overlaps to each other. Alright? So, meron itong sp3 na nag-overlap to the sp3 of another central carbon. So, you have a carbon-to-carbon bond, again, that arises from overlap, okay, at the end of one sp3 to the end of another sp3 orbital. Okay? So, kumbaga parang ganito. Itong carbon na to, meron siyang sp3, apat na sp3. The same with the other carbon, sp3. Now, itong bond na to between carbon to carbon, that arises because of overlapping of the end of one sp3 orbital and the end of another sp3 orbital. Okay, so when you say end-to-end orbital, okay, this would be the first mode of orbital overlap. Kapag sinabing end-to-end overlap yung nangyari, that forms sigma bond. Okay? When we say sigma bond, yung highest electron density resides on the bond axis. Along the axis, kung saan nabuo yung bond, highest electron density resides there or occupies there. Alright? Then you have to take note that all single bonds are sigma bonds. Okay? Ibig sabihin, lahat ng single bond that connects two atoms together, that is a sigma bond. Okay? Nabuo yung sigma bond ulit via end-to-end overlap. Yung end ng isang orbital nag-overlap sa isang end naman with the other orbital of an atom. So the other sigma bond here is formed naman between carbon to hydrogen. Ito, carbon to hydrogen collision ng orbitals nila. Okay, the same with the other side. Okay? So kapag end-to-end, diba end-to-end ng orbital, end ng isang orbital nag-collide with the other end of another orbital, that is end-to-end overlap. Okay, that will form a sigma bond. So kapag tinanong kayo, ilan yung sigma bonds na nabuo sa molecule ng ethane? Ilan yung sigma bonds na nabuo sa molecule ng ethane? So you have 1, 2, 3, 4, 5, 6, and 7. Okay, there are a total of 7 sigma bonds. Isang sigma bond doon nabuo between carbon to carbon. Okay, the rest of the 6 bonds, sigma bonds, are in between carbon to hydrogen bonds for this molecule of ethane. So yan yung tandaan nyo, all single bonds, okay, in a covalent bond. All single bonds are sigma bonds. So that would be the first type of covalent bond, sigma bond. This is formed via end-to-end collision, end-to-end overlap of orbitals. Okay, next. In the case of the molecule ethylene, so this is ethylene. Yung isang other, di ba, dalawa lang yung mode of orbital overlap forming two types of covalent bonds. Yung isang type pa, yung other type pa ng orbital overlap, it will be observed in the molecules of ethylene and acetylene. So let's start with ethylene. Oops. So for ethylene, take note na each of the central carbon is in trigonal planar shape. Okay? Naka-trigonal planar arrangement. Kasi each of the carbon merong 3 electron groups. Kapag tatlo yung electron groups that surrounds each central atom, then that is a trigonal planar shape. And kapag trigonal planar shape, ano yung shape na yan? Ano yung hybrid orbitals na yan? sp2. Alright? So, naka-sp2 hybridized each carbon atom for ethylene. Okay? So, itong carbon na to, meron siyang tatlong sp2 hybrid orbitals. Ito din, merong tatlong sp2 hybrid orbitals. Take note ha, kapag sp2, tatlo yung orbitals na yan. Kasi nag-mix ka ng isang s, dalawang p. So, dalawa plus isa, tatlo. Okay? Now, dalawa sa sp2 orbitals. Okay? Dalawa dyan sa sp2 orbitals of each of these carbon forms a carbon to hydrogen sigma bonds. Again, dalawa sa sp2 orbitals of each carbon forms carbon to hydrogen bonds. Ganito din sa kabilang side na carbon. Diba? So, dalawa sa sp2 orbitals for each carbon forms carbon to hydrogen sigma bonds. Kasi sabi natin, sigma bonds ay all, no? All single bonds form sigma bonds. No, nasaan ngayon yung isa pang sp2 orbital for each carbon? Yung isa pang sp2 orbital nila nag-overlap end-to-end. Okay? So, ito yon. Okay, again, isa pang yung pang-third na sp2 orbital. For each of that central carbon, it forms another sigma bond with the other carbon. Alright? So, ito yung nangyari. Again, each carbon, sabi natin, sp2, hybridized. Since sp2 hybridized, meron siyang tatlo. Ayan, tatlong sp2. Itong carbon din, meron siyang tatlong sp2. Dalawa sa sp2, it forms an overlap, okay, with the s orbital of hydrogen. Okay? Ibig sabihin, meron tang dalawang sigma bonds na carbon to hydrogen. Okay? Carbon to hydrogen for each carbon. Okay? So, yan yung overlapping ng dalawang sp2. Yung isang sp2 nag-overlap sa each other. Okay? Ayan. Okay, so those are sigma bonds. Bakit ulit sigma bonds? End-to-end overlap. End-to-end overlap. Yung end ng isang orbital nag-collide with the end of another orbital. Now, bakit may p orbital for each carbon? Okay, bakit may p orbital for each carbon? Recall that carbon has 4 valence electron. Now, in the case of ethylene, diba, ito yung isolated na electron distribution for the atom carbon. 1s2, 2s2, then, ayan, 2, 4, 2p, 2. So, merong 4. Nag-mix tayo. Bakit yung mixing hindi sp3, sp2 lang? Kasi, for this example, tatlo lang yung electron groups for each carbon. Tatlo yung electron groups for each carbon. Alright? So, ibig sabihin, tatlo lang yung na-mix. Okay? Isang S, dalawang P. So, 1, 2, 3. Forming 3 unpaired or 3 half-filled sp2 orbital. Ibig sabihin, meron pang empty. Meron pang empty na 2p. Okay? That is why, yung isang valence electron pa ng carbon is being occupied sa 2p orbital. Okay, so total of 4 valence electron for carbon. Okay, valence electron for carbon, 4 pa rin. Okay? Di pwedeng mag-sp3 ka. Kasi, yung sp3 dapat 4 yung electron groups that surrounds a central atom. In this case, 3 lang diba itong electron groups na to? Isang single bond, another isang single bond, dalawa, then isang double bond. 3 electron groups lang yan. Okay? So, 3 lang yung imimix natin na orbital. Okay? For hybridization. So, yung isa, yung remaining na valence electron ng carbon, nag-reside sa P, sa 2p orbital, which is being half-filled. Alright? Now, kapag may p orbital na yan, okay, so the same with the other carbon, meron din siyang p orbital. That p orbitals, kapag nag-overlap sila, side by side, okay, side by side sila, nag-overlap. Okay, hindi katulad ng sigma bond. Kasi 'di ba yung sigma bond, end to end. collision. Kapag p orbitals nag-overlap, side by side yan. Okay, forming a pi bond. Okay, kapag side to side or parallel overlap of orbitals for p, no? Overlap of p orbitals that will form a pi bonds. Okay, and a pi bond, it has its highest electron density above or below the sigma bond. Diba? Ito yung sigma bond. Okay, above the sigma bond, so in here, or below the sigma bond, doon nagre-reside yung electron density for a p orbitals that overlap side by side. Okay, so that is how this second bond in a double bond is being formed. Yung mode of orbital overlap ng p orbital is side by side. Alright? So, pag side by side ulit, pi bond. Alright? So, ito yung tandaan nyo. Kapag in a covalent molecule, nakakita ka ng double bond that connects two atoms. Yung first bond na yan is a sigma bond. Yung second bond sa double bond is a pi bond. The same with triple bond. You know? Kapag nakikita ka ng atoms bonded via a triple bond, yung first bond na yan is again a sigma bond. Ibig sabihin na buo yung bond na yan based on the hybrid orbital, and yung overlapping na buo via end-to-end collision. Yung remaining two bonds in a triple bond is a pi bond. Ibig sabihin, those are p orbitals that overlap side by side. Alright? So again, let's try to observe the side-by-side overlapping naman ng p orbitals in the molecule of acetylene. Okay? So for this molecule, each carbon is in linear shape. Diba? This carbon, itong unang carbon, on the left side, meron siyang dalawang electron groups. Isa, triple bond, isa, single bond. Ganun din, yung carbon na to on the right side, the same number of electron groups. So, naka-linear, okay, each of this carbon. So, pag linear shape ng hybrid orbitals is also linear. That gives us an sp, hybridized central atom. Alright? So, ibig sabihin, each carbon may sp. Okay, so this is an sp. Okay? Sp. Ayan. The same with the other carbon, meron siyang sp orbitals. Okay? One of its sp orbital overlaps, okay, end to end with the sp orbital of another central carbon. The other sp orbital overlaps with the 1s orbital of, ayan, hydrogen. Ayan. Forming a sigma bond. So, this is a sigma bond. Ito din, sigma bond, sp to sp. Ngayon, etong remaining two bonds are actually formed via side-to-side overlap of p orbitals. Okay? Sige. So, yung nangyari dito is from the electron distribution of an isolated carbon atom, diba? From this distribution, ayan, ito yung isolated carbon atom. Okay, C6. Since nakalinear yung arrangement ng each carbon, sp hybridized lang. Okay, yung gagawin natin. So, mix ka ng dalawa lang. Okay, so sp with unpaired electron each para makabuo ka ng sigma bond, then sigma bond, yung una, sigma bond. Alright? Now, a carbon has 4 valence electron. That is why meron pa siyang remaining na dalawang 2p. Alright? So, sa 2p, merong half-filled. Alright? Okay, that is why each carbon, meron silang dalawang half-filled 2p orbitals. Okay? That gives, okay, a pair of pi bonds. Alright? So, nagkakaroon din ng side to side. Ito yung first half-filled 2p orbital ng carbon on the left side. Ito naman, okay, yung ka-overlap niya na 2p, half-filled. So, ito yung unang pi bond. Okay? Side to side overlap. So, since yung as observed, electron density obviously is either above or below. Yan yung unang pi bond. That is a side-to-side parallel overlap. Yung isa pang pi bond, it is being formed side-to-side overlap then. But this time, ito yun. Okay? Nakaharap sa'yo. Okay? Okay, nakaharap to sa'yo. Nakaharap. Okay, front. Ito yung front. Back. Ito yung back. Okay? Ayan. So, pwedeng yung side-to-side overlap ng dalawang p orbitals forming a pi bond. Yung electron density is in front. Ayan, in front of the sigma bond or at the back of the sigma bond. So, p orbitals nag-overlap, it forms a pi bond. Alright? So that is how the second and third bond in a triple bond is being formed. Yung mode of orbital overlap nila is side-to-side parallel. Okay? Particularly, yung nag-overlap are p orbitals forming a pi bond. Okay? So to summarize, no, in order for you to identify if it is a sigma bond or a pi bond, you just know how to count. Okay? Kapag nakakita ka ng atoms na bonded singly, a covalent bond, isang bond lang that connects that two atoms, automatic, that is a sigma bond. Nabuo yung bond na yan, end-to-end collision ng two orbitals. Kapag yung atoms connected by a double bond, isang bond na yan, unang bond is a sigma bond. Ibig sabihin, you have a hybrid orbitals that overlaps end-to-end. Then, the second bond is a pi bond, which is a p orbitals that overlap side to side. The same with atoms connected by a triple bond. First bond is a sigma bond, hybrid orbitals that results to end-to-end collision. Then the remaining two, okay, are pi bonds. No? Pi bonds. Ibig sabihin na buo via side-to-side parallel overlapping ng atomic ng p orbitals. Okay? Now, kapag tinanong kayo ilan yung sigma bonds in the molecule of ethylene. Ilan yung sigma bonds in the molecule of ethylene? So, bilangin nyo lang 1, 2, 3, 4, 5 sigma bonds. Alright? Ilan yung pi bond? Okay? Pi bond is only 1. Okay? Isa lang yung pi bond. And ito yun. Okay? Yung second bond in a double bond. Okay? The same with in the molecule of ethane. Ilan yung pi bonds kapag tinanong kayo? 3. Okay? 3 yung pi bonds. 2 yung itong dalawa are pi bonds. So, sigma, ito yung pi bonds. Alright? And all the single bonds in a covalent bond are sigma bonds. End-to-end collision of 2 orbitals.